Good day, class. Today we will be discussing about minerals and some common rock forming minerals. Okay, so the picture you're seeing right now is a giant quartz formation in Mexico. They usually mine quartz for the purpose of jewelry or gemstone, for the purpose of making glasses, for buildings and constructions as refractory materials, and there are also several industrial uses of quartz. But we will not only tackle quartz today, okay, because there are several minerals found in nature. Our objectives today is that we are going to identify and describe the different properties of minerals. Next, we are going to group the minerals based on chemical composition, and lastly, we are going to identify some common rock forming minerals. Okay, so let's proceed to the main topic. Minerals. When we say minerals, they are usually naturally occurring crystalline substances. Okay? They are made up of different crystalline structures which are usually hard, much harder than the rocks. Okay? So mineral is also known to be the building blocks of rocks. Let's say for instance we have three main types of rocks: igneous rock, sedimentary rock, metamorphic rock. These are the different types of rocks, but all rocks, it may be igneous, it may be sedimentary or metamorphic, they contain minerals, simply because minerals are the building blocks of rocks. Without minerals, then rocks could hardly form. Okay? Now, in the Earth's crust, there are two types of materials, such as minerals and rocks. Okay, so that's the main composition of the Earth's crust. Okay, minerals are usually made up of crystalline structures. They are quite shiny, colorful. They are usually harder than the rocks, while rocks are more dull in color, and they are the mixtures of different types of minerals plus organic compounds plus other substances, such as debris of a weathered rock, such as the broken substances of an old rock or mineral as well. Okay? So talking about color, minerals are usually colorful. Rocks are usually dull in color, but it's not really reliable if we tend to distinguish that a mineral is considered to be colorful while rocks, they are considered to be dull in color. Okay? How about colorful rocks? Could we consider them as minerals? There are some colorful rocks in nature. Okay? That's why we don't consider color as a concrete evidence in determining mineral from rock or in determining rock from mineral. So there are different characteristics that we must consider. Okay? Now, first characteristics of minerals, we have a mineral is naturally occurring. This picture is an example of halite. Okay? So halite is a type of salt wherein it occurs naturally near water bodies, near the salt water bodies. Okay? So when we say naturally occurring, these are minerals that has been formed by geologic processes without any human intervention. They are not made by human beings, but they occur naturally in the environment. Okay? They just grow there. It has something to do with heat, pressure, temperature, causing them to form random crystalline structures. Okay, so that's the first characteristic of minerals. Next, we have inorganic. When we say inorganic, minerals are formed by inorganic processes and does not contain any organic compounds. When we say inorganic, these are usually made up from the non-living substances. Okay? When we say organic, organic matter are usually the remains from a living substances, while inorganic, they are usually the remains of the non-living matter. Let's say, for instance, a gold was melted. Gold is considered to be inorganic, pure substances. Okay? Now, the gold is melted. Even though it deforms into different structure, but the source or its components are made up of inorganic substances. Okay? While organic substances, they are usually coming from the remains of a previous living organism. Okay? So inorganic, they are pure inorganic. First, a mineral is classified as naturally occurring. Second, a mineral is classified as inorganic substances. And they are usually pure substances. Okay? No organic compounds are mixed within a particular mineral. Okay? Now, third, we have solid. Okay? So solid is a characteristic of a mineral that exhibits stability at room temperature. When we say room temperature, it is approximately 30 degrees Celsius to 35 degrees Celsius. Okay? So that's the approximate. Okay? Now, during that specific temperature, if a mineral is exposed in a room having a specific temperature, it shouldn't melt. Okay? Now, there are minerals that melt in room temperature. Okay? They are usually liquid in form. That's why there are some exemptions about this rule, about this characteristic. Okay? But majority of the minerals are usually solid at room temperature. Okay, so this one here is an example of a feldspar. Okay, feldspar. Okay, now next we have crystalline structure. Okay, so a crystalline structure cannot be seen by the naked eye, but its physical appearance reflects the arrangement of atoms having its crystalline structure. Okay, so it refers to the arrangement of atoms in a repetitive manner, in an ordered manner that makes a certain mineral very hard. It is usually durable, just like the diamond. Okay, so a diamond is usually used in industries, in in jewelries as well. Okay, in fashion. Okay, now there are different shapes of a mineral. Okay, so let's say, for instance, cube. Galena, when broken down into smaller pieces, okay, each component of the galena is like a cube. Okay, so if this will be broken down into smaller substances, it turns out to be this one, having a cube-like structure. Okay, so that's a shape of a mineral, one of the many shapes of a mineral. Now, we also have another shape, the rhombic shape, such as in topaz. Okay, so it has several sides when broken down into smaller pieces. Usually, the shapes of the minerals are more likely observed once they are in their broken state. Okay? So, if we tend to break them apart, if they look like this one, then it belongs to the rhombic shape of a mineral. Okay? Next, we have hexagonal. Okay? The physical structure of a graphite mineral doesn't seem to be hexagonal, but the shape also is considered from the arrangement of atoms. So, when we say the arrangement of atoms having hexagonal structure such as graphite, we have 6 carbon atoms forming a hexagonal shape, such as this one. Let's say, for instance, we have 6 carbon atoms here. Carbon, 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 carbon. There. It is arranged in a repetitive way, creating a hexagonal structure. Okay? So that is considered to be the shape of a graphite from its arrangement of atoms being hexagonal. Okay? Great. So let's proceed. Next, we have the tetrahedron. Okay. The quartz, for example. As what you have noticed, the tip of a quartz is usually hexagonal. No, no, no. Sorry. Is usually tetrahedron. Okay? Tetrahedron having a triangular shape at the tip of the mineral quartz. Okay? Now here. Okay? So we have the tetrahedron shape. Okay? Next we have the amethyst. Okay? Is considered to be an octahedral in shape or octahedron in shape. Okay? So it is considered as a mineral, an expensive mineral that when broken down into smaller pieces, it will behave into this particular shape. So we have amethyst. Okay? Next, we have tetragonal prism. Okay? Such as the chromatite. Okay? Tetragonal prism meaning it is quite tetrahedron regarding with its body, but its tip is usually prismal, okay, having a prism-like shape on the tips of a particular mineral, chromatite. Okay, so its body is usually tetragonal, and the tips are usually prismal as well. Okay, such as the chromatite. Now, there are also different chemical formula in a particular mineral. Okay, there are different chemicals present in different minerals. Okay, so fifth properties of or characteristics of minerals is that they must be represented by a chemical formula. Okay, so most minerals or chemical compounds therefore represented using fixed or variable chemical formula. Okay, when we say variable chemical formula, this can be added with another chemical changing the mineral name, changing the entire mineral composition. Okay, but talking about its chemical formula, there are specific chemical formula per mineral. Let's say, for instance, quartz. It is made up of silicon and oxygen. For halite, it is made up of sodium and chlorine. For calcium carbonate, it is made up of calcium, carbon, and oxygen. For gold, it is usually a pure element from aurum or gold itself. Okay, and we also have Na plagioclase. So there are different variations of these minerals. This portion here could be changed and it will become into a different mineral. Okay, just a slight modification of the chemical formula will produce another type of mineral. Okay, so that's the fifth characteristic of a mineral. It must be represented by a chemical formula. Okay, so here I'm just zooming in the minerals I have mentioned earlier. Okay, quartz, halite, calcium carbonate, gold, and plagioclase. Okay, so all of them are represented by a chemical formula. Okay, next we have mineral properties. Okay, so talking about mineral properties, we are referring to the chemical composition, we are referring to the luster, if it's either non-metallic, transparent, or translucent. Okay, if they may be soft or hard, if their color will react to a certain chemical, if their color will uh, mark in the streak plate. Okay, so that's another properties of minerals. Next, we have streak. Okay, so the streak of halite, by the way, we are referring to a certain mineral halite. Okay, halite contains different properties. Okay, but in general, it doesn't apply only to halite. It applies to all other minerals having different properties of chemical composition, luster, hardness, color, streak, crystal form, cleavage, specific gravity, and other properties, such as a salty taste, which is unique for the salt or halite. So now let's proceed to the different properties of minerals one by one. Okay, first let's have luster. Okay, luster is being referred by the quality and intensity of reflected light exhibited by a mineral. Okay, if it is shiny, having a resplendent shine similar to a polished metal, then it is considered to be metallic. Okay, such as the gold itself, silver, they are having metallic properties. Okay, metallic luster. Okay, next we have the non-metallic properties of mineral. So they are usually vitreous, glassy, and they are usually adamantine, such as the diamond. They are usually glassy. Okay, resinous, silky, pearly, dull, or greasy. When we say metallic, light cannot pass through, and it doesn't contain a shiny surface wherein reflection can be seen, unlike the metallic. Okay, so when we see a metallic mineral, we can see our reflection. Okay, it's quite similar with the property of a mirror. That's why it's very shiny, that our image can reflect in a metallic mineral, while non-metallic mineral, the light cannot reflect back, it gets absorbed. Okay, or some will be reflected back, but only just a bit. Okay, next we have another property, hardness. So there are different measurements of minerals. They can be soft or they can be hard. Okay, so how are we going to measure the hardness of a certain mineral? Using the Mohs scale of hardness, a mineral is thus the hardness of a mineral is measured through scratch resistance or scratch test. Okay, based on the ability of a harder material or mineral to scratch a softer one. Okay, so this was designed by the German geologist Friedrich Mohs, which was named after him, Mohs scale of hardness. Okay, so how are we going to measure the hardness of a certain mineral? Through the use of Mohs scale of hardness, we are able to measure the qualitative scale of a mineral's hardness, but not the quantitative. When we say qualitative, we just compare that mineral A is harder than mineral B. Okay? When scratched together, if mineral B scratches mineral A, without damaging mineral B, then that's the other way around. So the qualitative aspect is that mineral B is harder than mineral A. So that's for the qualitative aspect. But for the quantitative aspect, we cannot provide a numerical value giving its exact, accurate hardness scale. Okay? Next, the test cannot be used to accurately test the hardness of industrial materials. Okay, so there are different industrial materials which are using minerals, but through the Mohs scale of hardness, we can only determine that a diamond is harder than the gold. Simple as that. But we can't determine the numerical value. We have scale 1 to 10. 1 being the softest, 10 being the hardest. But that's it. We cannot uh, provide a certain value wherein how hard is the diamond compared to the hardness of gold. Okay, so we know that diamond is harder than the gold, but regarding with the specificity of its uh, hardness, then we are having no data to provide. Okay, so the specific hardness is only given by 1 being the softest, here, soft, and 10 being the hardest. Okay, hardest. Hardness 1 is represented by the mineral talc. It can be compared to the pencil lead. Okay, to the pencil lead. Now, have you observed upon sharpening a Mongol pencil, if you tend to scratch the lead of your pencil, it gets uh, scratched, turning into pieces, right? That means that our nail is harder than the pencil lead. Okay, so that's why the fingernail is compared to the hardness of the mineral gypsum. Okay, approximately the hardness of our fingernail is 2.5. Comparing talc and gypsum, talc being scratched by gypsum, meaning to say that gypsum is harder than talc, while talc is softer than the gypsum. Okay, that's just it. The qualitative explanation of a certain mineral's hardness. Okay, next, calcite. Calcite can scratch gypsum and talc. Therefore, calcite is harder than gypsum and talc. Okay, good example here is copper penny having a 3.5 hardness. Okay, you try to observe a certain penny, okay, which is having a 3.5 hardness. Okay, now its hardness can possibly scratch our fingernail. Okay, meaning to say that the penny is harder than the fingernail. Okay, therefore, the penny is equivalent to the hardness of calcite, which is number 3 in hardness. Okay, followed by fluorite, followed by apatite, followed by orthoclase, quartz, topaz, corundum, and diamond being the hardest. All the other minerals listed above can be scratched by the diamond, simply because the diamond is the hardest among the other minerals. Okay, now these are the minerals representing the Mohs scale of hardness. Talc being the softest, followed by gypsum, followed by calcite, the harder one, becoming harder and harder, fluorite, apatite, and here we have diamond being the hardest mineral in the Mohs scale of hardness, which is 10 in the hardness of the Mohs scale of hardness. Okay? Now, there are also other mineral properties, such as crystal form or habit. Okay? So it refers to the external shape of a crystal or group of crystals which is displayed or observed as it grow in an open space. Okay? Now here, they are usually determined by the shape of the mineral during its cleavage or fracture. Okay? So we can determine the shape or the crystal form of a certain mineral if it's broken down into smaller pieces. Okay? So crystal shape can be prismatic, tabular, bladed, platy, reniform, and equant. The shapes we have mentioned right now belongs to the habit or the mineral habit or a crystal form. Okay, here, a mineral that do not have a crystal structure is described to be amorphous, having an irregular shape, having an irregular crystalline shape. Okay, such as this one. Okay, as what you have noticed, it doesn't possess any crystalline structure. It's more on a rock-like structure. Okay, so it's considered to be amorphous. Its shape is irregular. Okay, so here we have different shapes or different crystal form or crystal habit. Can be cubic, tetragonal, triclinic, orthombic, hexagonal, monoclinic, and trigonal. So these are some of the crystal forms found in a mineral. So we have examples here. We have amethyst. Okay, which shape does amethyst possess? Okay, so going back here, it's more on tetragonal, right? Being the shape of the amethyst. Okay, followed by calcite, followed by garnet. Okay, so the garnet here is the white mineral. Okay, so we also have the galena here, the metallic mineral, gold, and pyrite. Okay, so these are some of the examples in which they possess different crystal shapes or crystal form. Okay, next we have streak. Streak is the color of the mineral in its powdered form, and it is usually the most accurate method in determining the color of a certain mineral. Okay, so just like this one here, as what you have noticed, they are usually black or darker in color, but when scratched in a strict plate, so the white plate here, this one, the white plate, is considered to be a strict plate. Strict plates are usually white porcelain or black porcelain. Okay, so white porcelain or white streak plate determines the color of darker minerals, while black streak plate usually determines the color of a lighter mineral. Okay, since this is black or darker in color, so it needs to be a white, it needs to be scratched in a white plate to show the contrast, to show the actual color. Okay, such as this one. If we tend to scratch uh, this mineral here, it appears to be black in the streak plate. This one here, it's black as a whole, but when scratched in a streak plate, it's quite reddish. Okay, so this one here, it's black in color, but when scratched in a streak plate, it's more on dirty white, off white, or what you call that one. Okay, more on what do you call this? Flesh in color or dirty white in color. Okay, so here the streak shows the real color of a mineral in its powdered form. Okay, this is a streak. So here, okay, so it's different from the whole mineral. Once we scratch it in a streak plate, then it provides its real color in powdered form. Okay, so this is streak. Okay, the color of a mineral in its powdered form. Next we have cleavage. Okay, so minerals have cleavage. Okay, it's the property of the mineral to break in pattern, in planes. Okay, so they break along specific planes of weakness to form smooth, flat surfaces. Okay, so as what you have noticed here, there are different directions of a mineral cleavage. They can be seen if we break down bigger minerals into smaller ones. Okay, so such as this one. Okay, here, such as this one. Quartz and rose quartz. Okay, here, mineral without cleavage is considered to be mineral without cleavage. Example, quartz. Okay, so there are also minerals that do not possess any cleavage. Okay, so instead of breaking in pattern, they break in random structures, not into a uniform structures. Okay, so they do not have breakage, such as quartz crystals. Okay, while cleavage in one direction, such as the muscovite, if we break the muscovite, it will always be in plane sheet. Okay, having a single plane, having a single direction. Okay, so it is constant. It breaks in constant direction. Its cleavage is always in a one directional breakage. Okay, next we have cleavage in two directions. If we break down a feldspar, it follows a specific pattern. Okay, such as this one. So it breaks into two directions. So its cleavage is two directional. Next we have three directional cleavage. Okay, such as in halite. Okay, meaning it breaks into three planes. Okay, so here muscovite, it breaks only in a single plane, in a single direction. Feldspar breaks into two planes, into two directions, while halite, it breaks into three planes into three directions. Okay? We also have cleavage in three directions, but its angle is changed. Okay? Its angle is different. So as what you have noticed here, it's more on 90-degree angle, the breakage of halite, but for calcite, it's more on acute angle, okay, regarding with its breakage. Okay, so the other side is acute, the other side is obtuse. Okay, so it breaks into three directional breakage. Okay, so that's for calcite. Next, we have specific gravity. Okay, so the ratio of the density of the mineral and the density of the water is being measured to determine a specific gravity of a mineral. This parameter indicates how many times more the mineral weighs compared to an equal amount of water. Okay, so let's say for instance, if a mineral is placed in a water having similar ratio, let's say for instance, a mineral that weighs, let's say for instance, uh, 20 grams is placed to the equivalent volume of water. If it sinks, then the specific gravity of a mineral is much denser than the water. But if the mineral floats, then its specific gravity compared to the water is less dense. Okay? If it floats, then the water is heavier than the mineral. If it sinks, then the mineral is heavier than the water. Okay? So let's proceed. There are also special properties of minerals, such as magnetism, odor, taste, tenacity, and reaction to acid. Okay? For example, we have magnetite. Okay? It is usually magnetic. Sulfur has a distinctive smell. Imagine you're smelling a sulfur soap. For example, Dr. Wong's sulfur soap. Okay? Its distinct smell is very observable. Okay? Having a strong odor, so that's one property of mineral, having its unique odor. Next, we have halite, which is salty. Table salt, acid, okay? Usually salty. And last one, we have the calcite. It fizzes with acid. Fizzes meaning there is a fizzing sound. It reacts to an acidic solution. For example, calcium carbonate being placed in Coke. Okay, Mentos having the similar properties of a calcium carbonate, meaning it is basic, while Coke is acidic. So when you place a certain basic substance mixed with acidic substances, then it creates a fizzing sound. Okay, mura siyang musiyok. Okay, so these are the special properties of minerals, such as magnetism. We have fluorescence, and they also usually glow in the dark, having the fluorescence of a certain mineral. And lastly, we have the fizzing sound. Okay, it reacts to a certain acid. Okay, so those are some of the properties of minerals. Okay, now let's proceed to the different classifications of minerals based on their chemical compositions. Okay, so when we say silicates, these are minerals containing two most abundant elements in the Earth's crust, such as silicon and oxygen. Okay, so Once it contains silicon and oxygen, automatically it belongs to the silicate group. Okay? Next, we have here its chemical structure and the formation of mineral such as silica, okay, or quartz as well. Okay? Now, here it contains one silicon atom and four oxygen atoms, creating the silicates. Okay? If silicates, it contains silicates and oxygen. Okay, simple as that. Next, we have oxides. So minerals composed of oxygen and iron combined with one or more metal ions. Okay, so if the oxygen binds with a metallic substance such as iron, then it forms the oxide group. Not just iron, but there are also other metallic elements or metallic minerals such as copper, such as gold, such as silver. Okay, if they bind to an oxygen and ion, then they will form into oxides. Okay, next we have sulfates. These are minerals containing sulfur and oxygen. Careful with our elements here, simply because you might get confused to the combinations of oxygen. Okay, first we have silicon plus oxygen, creating silicates. Next we have metallic ions plus oxygen, creating oxides. Next we have sulfur and oxygen, creating sulfates. Okay, next we have sulfides. Okay, so minerals containing sulfur and a metal. Some sulfides are sources of economically important metals such as copper, lead, and zinc. Okay, so here we have sulfur plus another metal, giving rise to sulfides. Okay, so we have the chalcopyrite or the chalcopyrite, galena, and the pyrite. Okay, so here we have metallic substances such as copper and zinc mixed with sulfur, giving rise to sulfides. Okay, so that's the fourth classification of mineral. Next, we have the carbonates. Okay, when we say carbonates, these are minerals containing carbonate group, meaning they contain carbon and oxygen elements, okay, including hydrogen. But the main interacting elements here are carbon and oxygen. Okay, so we have carbon and oxygen. So they are the ones interacting directly. So hydrogen interacts with oxygen, but it doesn't interact with carbon. Okay, so if a certain mineral such as carbon and oxygen interacts with one another, then they are considered to be in a carbonate group. Okay, so native metals or native elements. Okay, so these are minerals formed as individual elements. Okay, first category of native elements, we have metals and intermetals. These are minerals with high thermal and electrical conductivity. Okay, similar as the properties of metallic substances. Okay, wherein heat can easily pass through, wherein electricity can easily pass through. Okay, next we have semi-metals. They are usually poor conductors of heat and electricity. Okay, so minerals that are more fragile than metals and have a lower conductivity. Okay, more fragile than metals. Okay, And lastly, we have the nonmetals. They are the non-conductive metals. They are usually glassy in appearance, such as sulfur and diamond. Okay? So here we have some examples of we have metallic element or metallic mineral. We have the semi or the non-metallic. Oh, no, no, no. We have the semi-metallic element. We also have uh, the non-metallic element. We have sulfur. Okay? So we have the semi-metallic and the non-metallic minerals. Okay? Next, we have halides. Okay, we're almost done. Halides are minerals containing halogen elements combined with one or more metals. Okay, halogen elements wherein it combines with fluorine, oxygen, and chlorine. So this is an example of a halide element or a halide group of minerals. Okay, so to sum it up, these are the classifications of our minerals based on their chemical compositions. Okay, so when we say native element, we have gold, bismuth, diamond. When we have silicate, it contains silicon and oxygen. When we say oxide, it contains oxygen combined with a metallic element. Okay, sulfate, we have the combination of sulfur plus oxygen. Sulfide, meaning there's the presence of sulfur combining with another metallic element. Okay, next we have carbonate group, carbon interacting with oxygen, and halide, we have the halogen groups such as chlorine, fluorine, and halite interacting with one another together with the oxygen as well. Okay, so that ends our discussion. I hope you have learned something new today, and thank you for staying until the end of the discussion. And if you have any other questions or concerns, you can message me through MS Teams and Facebook Messenger. Then I'll be able to assist you if you're going to raise your concerns. Okay, so I guess that would be all. Thank you everyone for being around. Keep safe. God bless and bye bye.